The UGRLS Mark I, the Unmanned Ground Robot Laser System.
For the overview of our project, we have constructed an unmanned ground robot that can traverse terrains while being remotely controlled. Concurrently, it will output a video feed that can be used to observe the surroundings. There is a mounted laser diode that the robot can shoot obstacles or objects, which is controlled by a computer system. The objective is to increase situational awareness regarding locations unsafe or unfit for humans. This provides improved intelligence, surveillance, reconnaissance, transportation, and hazard damage assessment abilities. Our robot can be utilized to simulate many real-world circumstances in which the goal is to minimize human risk. For our equipment list, we used many of the parts that were similar to that given at the robot. However, we used upgraded MG996 servos, a laser diode, a phone/computer which are used to operate the robot, and a 3D printed mount which is used to mount the phone onto the robot. For the motivation, we were very passionate about having a remote-controlled vehicle that can detect obstacles or targets and conduct surveillance. This can be used for a variety of situations that can help save lives and minimize possible threats by not requiring human operation. We are inspired by the Guardian Mark I, as seen on the right. An Arduino Uno board is even used as the main control system for the Guardian. This allows add-on modules to be connected, which enables features such as Wi-Fi communication, GPS, and numerous sensors. For our project, we decided to add a laser module to serve many purposes.
The ground robot is an unmanned vehicle that can be driven using the key inputs from the WSAD keys. And this is for movement. And to look around, we use the mouse. And the mouse operates in the X and Y directions, which is horizontally and vertically. So when we move the mouse and the keys, it's sent as coordinates to the Arduino, and that's what moves it. But then we mounted a camera device on the servo, and this uploads a live feed to a computer monitoring system. And we attach the laser module on the camera mount. So the laser looks wherever the camera looks. And the software is used for this were Arduino and C#. And C# is a programming language used similar to C++. For our objective/realistic applications, we wanted to make a robot that can be used as an unmanned machine that can be operated in hazardous situations, such as like in warfare. But specifically, we're focusing on the laser aspect, and the laser can be used for cutting and shooting. And the laser attachment can be replaced with any device for any situation, such as rangefinders, missiles, or any other artillery. And this could accomplish many tasks or applications, such as surveying, scanning, and making repairs, or to gather intelligence in unpredictable terrains. But for the purposes of this project, we are going to be popping a balloon.
A very complex circuit diagram can be seen here, which basically just tells you that each pin was connected to. We did use pretty much every pin on the board except for 1 or 2 pins that we didn't have a use for. Now, our group actually wrote 2 different pieces of code for this project. As for the flowcharts, the C# program sends serial data to the Arduino over the COM port. This program detects 3 things: mouse movement, keyboard press, and mouse click. When it detects one of these 3 things, it will send a different set of serial data that is then parsed to reveal the variables that will control the Arduino. As for the Arduino flowchart, when it receives serial data from the C# code, it is then parsed into 3 different categories: servo movement, robot movement, and laser diode on and off. Depending on what the user inputs, the robot will act accordingly. For instance, with the keyboard, pressing the W key will move the robot forward, and the S key will move the robot backwards. As for our physical demonstration, a quick functionality test is necessary to show you exactly what our robot does. As you can see from the video, I use the mouse to move the servos around. I use the WASD keys to move the actual motors of the robot, and then the clicking functionality turns the laser on and off. As for a brief look through of the code, this is the form we use to control the robot, and then this is the actual code that was used to determine what was pressed, what was clicked, what was moved around and sent to the serial monitor. On the other hand, for the Arduino section, it's quite simple. We just labeled all the pins, we set up a bunch of functions for the movement, and then we set up a bunch of parsing of data to actually get the necessary numbers to move around with the necessary arguments. This quick in-action demonstration shows you how we plan on using this robot. With a camera attached to the robot, the user can view exactly what the robot is seeing and then can control everything without moving from their current location. Our robot is on a mission to pop an orange balloon, which represents an object either needing to be destroyed or needing to be welded in order to fix a problem. As our robot moves closer and closer to the balloon, you can see our robot checking the surroundings to verify that nothing unstable might drop onto the robot. With this, the robot begins to close in within range of the final target and sends off test fires to verify the laser apparatus is working properly. Once it is ready, it begins to cut through the balloon until it eventually pops. After completing its task, the user will then drive the robot back out to wherever it needs to go, whether that be back to its original location or onto the next target. But this demonstration should hopefully have given you a very rough idea of what type of project we chose to pursue this semester.